Good morning and welcome. My name is Laszlo Erdodi, and the title of my presentation is Next Generation Hacking Using Artificial Intelligence. So first of all, I would like to introduce myself. I'm working as an associate professor currently at the Norwegian University of Science and Technology, but I'm also a senior penetration tester at Experis Cyber. I am the trainer of the Norwegian National Students hacking team, and I'm also an EC-Council certified ethical hacker. But the main point is that my research topics are the offensive security with artificial intelligence, with machine learning, and also cybersecurity in power systems. You can see my email here, so please don't hesitate to contact me if you have any question. I'm starting my presentation with a motivation, because hacking with AI is something which sounds like inevitable. So if we take a look at the technological improvements during the last years, we can see that in many fields we could see success stories. If we are talking about autonomous driving or maybe surgeries, and I didn't mention Sophia, the human robot, or some logic games that machine learning agents can solve, and they are very efficient and good in that fields. So the question is somehow inevitable to ask: what is in the future from the point of view of offensive security, and what do we should expect in the future? So the aim of this presentation, and also the aim of the whole research that I am doing and doing together with my colleagues, so it's a joint work. I will mention them when I'm going to the appropriate slides. But the aim of this research is to analyze what is possible with machine learning. How can we develop an agent that can autonomously carry out penetration testings? So it has a very positive motivation. So we would like to help the community to help to protect the system and to carry out advanced penetration testings in another way, using machine learning, which makes it cheaper, and we can repeat it several times without involving expensive human experts. On the other side, I have to mention that it can be a little bit controversial, because we don't know what to expect. So we can say that the future with the AI is bright, but of course it's not that obvious. So I can just talk about some military usage of machine learning. You can see some pictures, but also deepfake is quite popular nowadays, and let's mention the voice cloning, which kind of scary as well. But I would like to emphasize that we have a quite positive aim, and the aim is not to create a Skynet or something. So we would like to use it in a positive way for some good purposes, and that's how I present this. Yes, another question that has to be answered is what was already done in that field. Of course, machine learning was used in several fields of cybersecurity. So we can mention threat identification, we can mention many successful pattern detection examples. Let's talk about malwares or other attack patterns can be detected using the relevant machine learning technology, and of course behavior analysis and phishing. But all in all these things happened on the defensive side, which is good. But we have to ask, what about the offensive side? First of all, what has been done already? And it's significantly less that was carried out on the defensive side. And also we have to ask, do we need it at all? Do we introduce some new risks? Definitely not. But if we don't research on that, still it will appear. And it's better if we are prepared. And we would like to do that. And we would like to analyze all the options. And that's the aim. And that's again a little bit of the motivation. So the need for machine learning hackers, I really think that it's something really useful that we really need in the future. So you can see some of the arguments I put here. So hacking, first of all, hacking in a controlled environment is very useful for the community. So let's talk about ethical hacking projects or red teaming exercises. But it's quite expensive and, of course, time-consuming. An expert, a human expert, would use tools as well. So somehow some kind of automation already started. So we have many good tools. And of course, it's not possible to analyze all options without using these tools. But on the other side, we also need the expert, the experience and the knowledge, the background information, and all the things that a well-experienced, advanced penetration tester have. It's needed here, and the goal is to develop something that is able to at least mimic the behavior of a human expert. So try to learn from previous examples when doing the offensive attack, and also to carry out some kind of logical understanding what was happening and find the best option for the attacks. So that's the motivation, and that's what we need to have such kind of agent. And as you can see here, human experts can also fail, and we would like to save some time and provide a promising solution for such activity. But of course, this is not easy. So just to summarize, so what I just told you, we would like to create something quick, which is reliable, which is precise, which always up to date. But on the other hand, it understands complex situations, can do reasoning, learn from previous example. So we would like to emulate a real human attacker, an experienced human attacker. It sounds like a mission impossible, as Tom Cruise would say, but we will do it. Let's see. So how we started it in 2020. We realized that this is a work that was not really covered by other researchers, but it's something that should have been. As I mentioned, in other fields, we could see some success stories, but in order to do some simplified tests, only to do some simplified tests, we still need a good attack environment that we can use for training the agents. And also what we need is to provide some knowledge for the agent, so some attack examples that can be used for the training. Of course, we have to choose the right direction for the machine learning, which way and how to do the machine learning, which machine learning paradigm to use. We need problem formalization, and also we have to carry out the training of the agent. The aim was also to do some kind of estimation, what is doable and what is not, and of course have a reasonable goal which is doable. And I have to admit that somehow I feel that I have to convince the community that this is something worth trying, because if we simplify the problem, we usually, not usually, but sometimes we get some feedback that yes, but this problem is so simple, and yeah, we shouldn't force something which is not a machine learning problem. So I would like to just prove the opposite, that this is really something has to be researched, and we're trying to do the best. And I'm now going to present you our preliminary results based on our research, and we have some examples and some conclusions regarding the task. So what you can see here, so maybe in 5 years or in 3 years I can tell you more, but still I can mention some preliminary results and some ideas and some ways what we tried and what was the experience about that. In order to create such tool, we need to have a good understanding of the characteristics for hacking. So just to highlight the basic characteristics, I think it's very important to mention that the agent that will carry out the hacking task need to have some kind of background knowledge. So have to have some understanding of the different attack types, have to have experience on that, and also have to have an ability to filter out the important information, so to evaluate the information and systemize the information. So an experienced human have to do that. And we need to carry out a good attack strategy to find the best way for the attack, and understanding the different situations, evaluate the situations, recognize known cases. But in addition to that, we need sometimes to invent something new attack ideas that has to be tried. And also the fast response time is something a must to have in that situations. So just writing some keywords, we need experience, we need time. For a human, we would call it patience. And also we need intuition and find something new and find the answers behind the observations and planning it and do some reasoning. So these are the main human characteristics as we see what is needed for that. And this is quite important to understand now, because we would like to choose the right approach to train the agent, and we have to, of course, simplify somehow the problem in the first round, and that what is has to be understood in order to do that. So the next question that has to be analyzed is the machine learning approach. Which approaches to use and how to use it, and maybe multiple approaches can be useful. So if we are talking about the main ideas, I mean the unsupervised learning, where the agent has to learn the word by itself using the examples, but without tagged examples. So there are no examples that was tagged by a human expert. Or we can also try it with supervised learning, when we have ready examples and the agent tries to learn the solution using the ready examples. Or we can use another approach, which is mainly used in game problems, solving of game problems, is reinforcement learning. When we have, you can see here some more details. So back to reinforcement learning, when we have an environment and the agent interacts with the environment, do the observations, and then take actions. So basically the reinforcement learning agent has an action set, and the agent is trying to use the best action for the next round. And also the agent has to observe the reaction of the environment and get some rewards. So we decided, because of that above mentioned thing, that maybe hacking is the closest to reinforcement learning, because it's an interactive process. So we have an attacker, we have a service. The attacker carry out something and observe the changes, and maybe get somehow some kind of reward if the action was successful, or penalty if it was something not useful, but maybe something very noisy. So we wanted to create it in a way that we have an agent, and in our next slide this is presented, and the agent has an action set and interacts with the environment, and the environment sends a reward and puts the agent to a new state. So this process is repeated, and in every step the agent has to choose the right next action. So let's talk about some concrete examples. So let's call the service a web service or a web page, and we have the attacker wants to attack the website. Of course, it's a quite complex environment, and there are many ways to carry out the attack. But first of all, the attacker, which is the agent here now, has to observe the website, what is possible, what kind of features are available, what are the functions, what are the parameters that we can use, what is the reaction of the site by sending some parameters. So it's like an interactive process where the agent tries out something and observe the reaction and get some rewards and moving to another state and trying something new. So we also simplify the problem as a capture the flag style game, because in that games the winning condition is clear. So if the attacker manages to grab the flag, then we can say that the event was successful. So the agent could hack the target, so get the flag, or we can also say that if it was not successful, because if the flag was not found. So in that world, we have an agent that carries out some kind of actions from an action stat, and it interacts with the environment, gets some penalty or reward, and the agent strategy is another important factor here, because the agent have ready actions that can carry out and have some experience of that, and the next action can be based on the previous experience, which is best in the current situation. And even in some percentage, the agent can try out exploration, so try out something new and see what is the observation with that new thing. So that's the basic idea. But for this approach, still it's kind of difficult to create an environment which emulate a real service. And also we have to provide some actions to the agent. And how to do that? So the agent can have a practically infinite number of actions that can be executed by the agent, and also how to observe the environment. So talking about web pages again, so if we receive a web page, an HTML code, what to do that? We have both some language, programming language code, for example, JavaScript. We can have error messages, which is related to the code. But on the other hand, we have some natural language as the page text. So maybe we also need to include some kind of natural language processing in that step. So I just summarized some initial concerns regarding the problem solution, but it's also something that has to be handled in the situation. But just talking about in general the problem itself, the action space is infinite. So the attacker can try out many different combinations. It's an infinite number of options. And also we have to define what is an action. So maybe we can provide some predefined request to the agent, or just keywords, just tokens. And the action and the agent would like to learn the exploitation without a structure. So the agent tried to create the structure of the attack itself. So what states should be considered? It's somehow defined by the actions. So we can say that these actions were tried, these actions were not tried before, but still we need to define the states. And again, it's true that we have infinite number of states here. So what is the environment? We need a huge number of random examples, so-called episodes in the case of reinforcement learning, that we can use for the steps of reinforcement learning. And as I mentioned, we need to observe the state change. What are the characteristics? How can we analyze the response by the service? We need some kind of simplification, obviously, and different level of complexity. So that was our initial approach for creating such an agent. And I'm going to tell you the examples we tried and the result we have so far. So first of all, we focused on web hacking. The reason is very simple, because this is the most popular protocol. And even though we have multiple web server applications in many different cases, so we have to consider a layered architecture, client side, server side, almost arbitrary website content, and of course a huge number of user inputs. A website can accept many different web parameters, even parameter combinations. And I haven't mentioned some header information, the sessions. So basically we have to consider many different states and parameters here, and also find a way how to evaluate the answer that is coming from the service, from the website in that particular case. But on the other hand, it's some kind of formalization. So we are using the HTTP protocol. So HTTP request has a very well-defined format, and also the answer is somehow structured. So we have a standardized input and standardized output, but still the complexity of the problem is huge. So in that case, we need to have more simplification and define easier problems first that we try to solve before we proceed to having something more sophisticated and that is able to solve arbitrary web hacking problem. So how we did that? Together with my colleague Fabio Zennaro, we created a model for web hacking, which is a formalization of web hacking problems with different abstraction layers. So the very first example, what we did is trivial, so coding it wouldn't be too difficult, but still that's the first abstraction of the problem. So the web page consists of objects, and the agent observes these objects. So the agent probably should know that on a website we have a starting page, which I'm just talking about static websites right now. So we have an index HTML, and what the agent should learn, how to find the flag. Of course, the flag is inside some of the files, and the agent in that very simplified case has two actions. The first is to read the file and find the links inside, so that we can find the new objects on the web page. And the second action is to search inside the file and find the flag. So all these actions can be programmed quite easily, and the result is just a web crawler. But still, we tried to solve it with a very naive approach using agent, and the agent had no background knowledge and had to learn which action to do when to find the flag, and the agent could learn it and find the optimal strategy. In the next level, we just complicated the case with the new actions, because normally on a website we can have some indirect connections to existing files. I mean that maybe there is no link for such file, but because of the context of the site, we can anticipate that other object exists there. So I mean here that talking about a website, probably what I would try is to check the robots.txt. There is no link for such file, but still we have to check if it's there, and maybe we can map some secret objects. Or based on the content of the file, if I see that it looks like some kind of content management system, why not to specify the WordPress login object, which was not linked inside the file, but still, because of the context, I have the guess that it's there. So this action is called a deep read, where we use the content of the HTML file to predict new objects on the website. It's not too complex program, but because there is no dynamic content of the sites. But in the next level, we defined a level or layer 3 simplification, a bit more complex, which can handle dynamic representations of the sites. So that means that one dynamic site can appear in multiple ways using the parameters, but we just restricted it to have one parameter for all objects, and the object has limited number of parameter values, not to have a state explosion immediately. Layer 4 and layer 5 contains the web request and multiple parameter combinations, as well as the session variables. And finally, in a much more complex case, an agent should map outside the web root objects, if it's possible, because of the web vulnerability. So the agent tries to map the outside world, what is outside of the web root. And in layer 7, the agent is able to carry out and create new objects on the website, maybe outside the web root or inside the web root, creating an attacking script, or just inserting a new database record somewhere. So that these are the complexity. And then we soon realized that first, it doesn't really make sense to try something on layer 1. So we solved layer 2 and have some specific solutions for layer 3. So the problem that we are addressing now is a website with one single parameter. But in the background, it's still very complex, because we would like to find the vulnerability and find the best way for the exploitation. So that's the aim here. And if you analyze the different web vulnerabilities, I can tell you that different vulnerabilities can be modeled in different layers. For example, information disclosure, it's kind of easy something. It can already appear on layer 1, somewhere inside the files, inside the objects. But for parameter tampering, we definitely need to start it with layer 3, where we have at least one parameter. And all the other web vulnerability types are analyzed, and we found that, for example, SQL injection is possible in layer 3 with a very simple one parameter website. But also with SQL injection, we can do much more, writing files on the web server with a select into out file statement, or also insert new records. So these are the layers, and we are trying to solve one specific problem for layer 3, a web vulnerability which is well known, and it's worth analyzing it in more detail. So we're going to analyze SQL injection now in the following few minutes. But before doing that, just a little analysis of the complexity of the problem. Even though I mentioned that in layer 2, we practically no dynamic content, just website files, still considering the actions, reading the file content and finding new objects, doing a so-called deep read, which try to find the hidden objects based on the content, and also searching for the flag, involves 3 actions for each file. So having 10 files on the websites, having 10 HTML files, for example, which means 30 actions, the state space already started to explode, and having a huge number of states in that very situation. On the other hand, if we consider web parameters as well, so you can see some numbers here. The number of web parameters so each web file can have different parameters. Take a look at the last case. We have 10 objects on the website with 5 parameters for each web object, and one parameter can have 5 different values, which is a very serious limitation, to be honest. But still, using this approach, theoretically, the number of actions it's infinite, quite infinite. Not infinite, you can see here the numbers, but in the real case scenario, it's extremely large, because the parameter value can be basically anything. And also the state explosion can be already experienced there. So from reinforcement learning point of view, some serious simplification has to be done for the first round. But also I have to mention that maybe it's not necessary to observe all the states and to have all the states. So it's not hopeless, but still the capacity, the calculation capacity is quite huge for such problems. In the following few minutes, I'm going to introduce you the environment that was created for generating examples for web vulnerabilities. As I mentioned in the introduction, to solve such issue, we need an environment that is able to create a random vulnerability with random parameters. So that environment was created as a joint work together with Robert Chetwin. He's a PhD student at the University of Oslo. And this environment is able to generate quickly many different problems that the agent can interact with. And also, talking about reinforcement learning, we need episodes, and the agent can send a request to the environment that I would like to have a new episode, and this environment is able to do that. I have some slides about that. I am going to explain that. But as you can read here, we are still emulating capture the flag style challenges. So the solution is obvious if we have it or not. And also, as I mentioned, a wide variety of vulnerable CTF style challenges are generated by this environment. You can see here one example description file which describes the main parameters of the vulnerable site. As you can see here, it's a Boolean-based vulnerability. It's a SQL injection as far as I see here. And the background database is also random. Also, we can define the maximum number of tables in the background database, the maximum number of columns. So that this description file was created for SQL injection. And also the type of the interaction. So the user, and here the agent, has one parameter, which is a login parameter that can be sent to the website. Also, we have to mention that the program is generated in a way that the website has an original query that is used by the site to evaluate the input parameter provided by the users. So the randomized database is generated, and that's what I was just mentioning, that we need a predefined vulnerable SQL query, which is part of the website, and normally the user has no knowledge about that. Just try to observe. The agent has to observe the right escape parameter, how to escape from the query, and how to continue the query and map the vulnerability. The environment is able to generate a vulnerable SQL query with different parameters, and you can see that random string delimiter and also randomly chosen SQL queries. And optionally, we can also introduce some kind of restrictions by input validation. So maybe not all the exploitation types are possible. So that's how we can force that, for example, union-based exploitation is not possible for one case. Then the agent has to realize that I have to do it in another way, and maybe doing the more time-consuming Boolean-based blind exploitation type. So this is the environment, and we inserted 2 slides here just to present the example, but also this solution is available online. So if you would like to try this, we really encourage all the researchers to try our environment for training the different agent. This is available on GitHub, and Robert knows the details, so please ask Robert about the environment and how to use it. You can see 2 slides about the different episodes that was created for this example. And now in that very case, the exploit that has to be used is quite easy. So it's a classical example of a SQL injection. So the user has to escape with a simple quote, and then finish the query with an or 1 equal to 1 and comment out the rest of the query. And this exploitation is quite easy. But in more advanced cases, the agent should realize that the exploitation is not possible with this simple bypassing mechanism, but has to carry out a union query. And for this, of course, it will be part of one of my next slide about the exploitation, but the agent has to realize that with the union query, first it has to map the right number of columns for the exploitation, and then the flag can be obtained in that way. So that was 2 examples for the environment, but as I mentioned, it's a random environment, and we use it to train the agent, and we have different sources for that to have more and more realistic cases for the website. So we don't really want the agent to learn that specific problem that we defined, but a quite random website with different vulnerabilities, with different parameter and different background databases. So that's the randomness is quite good, we believe. In the next few minutes, because I have to a little bit speed up because of the available time, I'm going to present you one particular solution that was done by me and 2 other colleagues. You can see that was done by Overt Sommervold and Fabio Zannaro from the University of Oslo. But when we started to create the solution, we decided that we have to have a quite simple environment. So we created simple websites with only 1 input parameters. So there is no dimension increase with multiple parameters. The parameter that was provided is processed by the server-side script, and it is inserted as a random query. So so we have the environment that I already introduced. And the background database has a limited number of tables. The easiest case when we have 1 table, which is used for the original query, with random number of columns, with the random number of rows. And we have another table that contains the flag. So basically, the agent has to modify the query in a way to have access to the second table and find the flag in the right position. We also considered cases when we had no vulnerability at all. So, of course, at the beginning of the exploitation, we don't know if we have vulnerability or not. So we have different type of vulnerabilities, but also this is one option, there is no vulnerability, and we measure the number of actions that is necessary to observe the missing vulnerability. So basically, it's not just an exploitation tool; it's a detection tool as well. For the different cases, we had structured SQL injection type when the agent has to use a semicolon and the new query can be generated, or union based when 2 queries are concatenated. In that case, we had to find the right parameters for column number matching, and also the Boolean based blind exploitation was emulated with some type of web pages, and in that case the agent has to play this true-false game if something can be seen or not. We also tried the time-based exploitation, and in that case we also simplified the case. We had 2 response time, a slow and a fast, and that means that one indicates one type of Boolean result and the other is the other. But in some of the cases, we randomly made a fast response slow because of the traffic. So that's how we emulated the traffic that can a little bit confuse the answer time. So in some cases, we made the fast response to slow because of the traffic issue. And that's how we force the agent to try everything multiple times. Also, we had other considerations here. How to provide an action space to the agent. We can try it with a structured approach or without structure. So we just tell the agent some tokens that can be used. In the easiest case, we just have the English alphabet. And the agent has to carry out all the combinations. It's a huge number of combinations, but that's how the agent can learn what is the good SQL query. In other cases, we provide SQL tokens that the agent can use. And in more complex cases we have here, or maybe it's not more complex, but somehow it's easier. But in that case, we provided a ready action set for the agent. So we had some actions that is good for observing the escape from the input as part of the original query. So we have no escape, quote, and quotation mark as well in different combinations. We provided some actions that are capable to carry out some specific exploitation types. For example, for validating structure-based SQL injection exploitation. Yeah, we provided, for example, one where the agent asked the select at version, the easiest query, just to verify if in that way it is exploitable or not. Also the same for union statement. And for the Boolean-based statement, of course, some string functions to make a Boolean expression here that was provided. On the other hand, I have to mention that for particular queries or for particular exploitation types, such as for the union exploitation, the agent has to observe the right matching column numbers, and we had to provide some predefined queries for that one, or actions, let's call it actions. And finally, when the agent finds the right way of the exploitation, we did the final exploitation as one step. So I mean, if you have a union-based exploitation and the vulnerability was mapped, I mean, we know the type of the parameter that the user can provide. We know how to escape. We know that union can be used based on the previous sections. We know that we need a specific number of columns in the second union query. So in that way, we could map the vulnerability, and we just use one action for the final exploitation. When everything is known, we don't need to explore the vulnerability anymore. We just have to exploit it, which is a bit misleading because we use it as one action. However, it's multiple requests. And let's talk about the result that we had. So what we observed, that we tried 1 million episodes, and what we could observe that the more episodes we have, the more states are explored. And after 0.9 million episodes, the agent could learn, you can see it in the picture on the right side, the agent could learn the optimal strategy for the exploitation. So you can see here. And after this, so basically we had exploitation and exploration action, which was randomly selected by the agent. But after we saw that the agent could learn the solution, we removed the exploration, and in that case, of course, the success rate jumped to 1, and that's how we had the agent. That's how we trained the agent. Yes, and now let's talk about the result. So as I said, the number of actions is not aligned with the number of web requests because we have this final step for the exploitation. But for the mapping activity, it's very well presented here that the vulnerability type was reflected by the number of actions that was carried out by the agent. So then we used 1,000 cases to test different vulnerabilities with the trained agent, approximately 200 cases for each vulnerability type, including the no vulnerability. So we had no time-based here, but we have all the other four, the stack-based, the union-based, the Boolean-based blind, arrow-based, and the no vulnerability. And what we could see that in 60% of the arrow-based cases, the agent could detect the arrow-based vulnerability in 2 actions, and in other cases it was 3 actions. What we could see that the most complex vulnerability mapping and identifying the necessary parameters for the exploitation was the Boolean-based blind exploitation, when we had to use, the agent used 10, 11, or 12 actions. But what was surprising for the first time, that the no vulnerability could be detected in 9 actions. What we thought that maybe that would be the most. But then we realized that maybe detecting there is no vulnerability is easier than detecting the exact type of the Boolean-based bind exploitation. So that's how we could carry out this action, and it turned out to be successful, and the agent could learn such a simplified problem that I emphasize again that we had a very simplified environment with a random web page, but still with one input parameter and a very well-defined action set, structured action set, but the results are very promising. So increasing the number of actions and the states, of course, and also providing more and more complex environment. Of course, the training time would increase, but according to our previous findings, it's too possible to do it in that way. And as a first or second step, the results are really, really promising. Soon I have to finish the presentation. But of course, we have some future perspectives, and the environment is ready, as I mentioned, but still it's never ready. We try to expand it and having more and more vulnerability types. And also the idea is to use some sophisticated environment based on real-world CTF write-ups. Thanks to CTF time, we have many write-ups. We just counted more than 100 write-ups for different unique SQL injection. And of course, we have much more. And based on that, we could create, I believe we could create a very good and better environment. Also, we would like to have an agent that can attack other vulnerability types, not only SQL injection, but maybe using the OWASP top 10. And in a more complex case, even the red team, blue team exercise can be carried out with both robots on both sides. That's maybe in the far future. On the other hand, we have to clarify some other research questions. How to observe the responses of the environment, of the service. We have multiple options here. Just observe the answer lengths. For a Boolean-based blind injection, probably that's enough. But for more sophisticated exploitations, of course, we can observe the web response. We can observe keywords. We can observe HTML elements, JavaScript elements, so some specific tokens, or maybe error messages. Or in worst case, or maybe that is also something makes it better and better, doing the human readable text and doing some kind of natural language processing to understand the meaning of the website. That also involves the increase of the action set and the state space. And of course, we have to consider how to provide the actions, as I already mentioned several times, that the structured approach is really promising, but of course it requires more capacity, resource capacity, calculation capacity to train the agents. But then in that case, we won't provide anything. The agent can use anything as an input. It's a quite random case. So these are the future perspective, and I think time is up. So I just finished the presentation, and I project again my contact details, and please send me any question you have, and I try to answer. So thank you for your patience, and goodbye.